Hi, this video is to talk about the fixed time period model. This model is an inventory model where we have a fixed time, which means every certain amount of days or certain amount of weeks, we place an order to complement our inventory. Okay, so in this one the time is fixed. For example, every Friday, every Monday I place an order to my suppliers. Let's take a look at this figure. So this is fixed time. So this is where I place an order, and then I place an order and an order comes, my inventory goes up, and then at the same interval of time I place another order, and then in the same interval of time I place another order. So the time, the period to place an order is fixed. It doesn't change. It's always every 15 days or every 7 days or every 10 days. What varies is the amount of units that I ask to my supplier. So what varies is the amount of units. Okay, the time is fixed, so what varies is the quantity. Okay, and this is the formulas, and this is the example we're going to be using. This is from our slides, and here is the information that you typically have in a problem. So when I go to Excel and I typed all this information here, let's take a look the pieces of information that we need. The average daily demand, D bar is 10 units. And so this is my D bar. Daily standard deviation, which is sigma D, sigma D. So how much my sales or my inventory varies every day is 3 units. How much I use of inventory? On average, I use 10 units, but varies. And sometimes I use more than 10 units. Sometimes I use less. The standard deviation is 3 units. Okay. So the review period is 30 days. So every 30 days, I place an order. Okay. That's my T, the time to place the orders is always 30 days. The lead time to get the orders is 14 days. So this is my L, my lead time is 14 days. 98% of demand should be met from items in stock. So I'm saying this is another way of saying that I want not stocking out probability of 98%. So probability of not stocking out, not stock out is 0.98. Because I have a probability, remember we have to turn this probability 0.98 into a z-score, and that's what we're going to use here in this formula. So let's find the z associated with this 0.98. Remember, to find z is equal norm dot s dot inv open parentheses, and then you select the probability, or you type the probability, and that's the z value associated. So this is z. And the units in inventory, I have 150 units in inventory now. So this is my I. So you see that we have, so this is the formula to compute the quantity that I have to order in the next time. So the quantity depends on my average daily demand plus how long it takes for me to review my to place an order, and also the lead time. So this is how long it takes to place an order, and the lead time to get the units, and I multiply by my average daily demand, and then I add on top of that whatever varies my demand during this period of place an order, the review period, and the lead time. So this is what the variability of demand during this period. And how to compute this, we have to compute this formula here. Okay, this is the only thing that we have to compute more than the pieces of information that we have here. So as continuing, you can see that we have z here, so we have z here, and we have y here, is y here. So the only thing missing to be able to solve this computation is this formula. So let's start with this formula. Let's call this sigma sigma um, sigma t plus L. Let's call sigma t plus L. Okay, which is the variability of demand during the lead time. This is what it means. Okay, so to compute this, the piece of information that I need is first t plus L. So I'm starting with this part here, t plus L. T plus L is equal to t plus L. And then now I'm going to compute the sigma d, which is the daily standard deviation of my demand. I'm going to square that to get the variance. So let's call this sigma d square. Okay, sigma d square. Sigma d squared is simply sigma daily sigma d multiplied by sigma d, which is the daily standard deviation. Okay, now I'm going to multiply those numbers. So this is going to be equal to, let's call t plus L multiplied by sigma d. Let's call sig d squared. Okay, so this is equal to this multiplied by this, and now the square root of above of this number above, so is equal to skrt, open parenthesis, select this number, and that's the variability of demand during the lead time. That's the amount of units. Now I can compute k. Okay, but to compute k, I have first to compute this multiplication. Let's do this. So let's call this d bar multiplied by t plus L. So d bar is equal to d bar multiplied by open parenthesis, or multiply, we have this computed here, t plus L. Okay, 440 units. That's the average daily that's the average demand during the lead time. So this is units. Again, this multiplication is the average daily demand during the lead time. This here is the daily variability during the lead time. Okay, so I have this right here. Now I have to compute this. So let's call this z multiplied by let's call square root, the square root of above, which we computed before. Oops. Okay. This square root of above is this here. Okay. So we're going to do equal the probability of the z value associated with the probability of not stocking out of 98% multiplied by the square root of above, which is the variability with lead time. So which means that I want to attend 98% of the variability of demand during the lead time, I need almost 41 units. Okay, so now I can compute my k. So my k is how much I have to order when next I don't know, day come to place an order, the review period come. So this is going to be equal to this number plus this number minus, we have this I here, minus 150. So this is the amount of units I have to purchase or produce when the next review period comes. Okay, so let's say we place an order every the first day of every month. That's the review period is 30 days, remember. So every day, first day of each month, I have to determine how much I'm going to buy or how much to keep in inventory. It varies from month to month, depends on how my sales were in the previous month and how many units I have in inventory. So this K varies. So this K this time is 331 units or 330.86 units. Next month, it will be a different amount. Okay, going back to our slides. So just to finish, in the fixed time period, the time is fixed, but the quantity varies. Okay? To compare with the other model, let me show you the other model. This is the fixed order quantity model. In this model, the quantity is fixed, but the reorder point varies. Okay? That's one of the differences. In the fixed order quantity model, the quantity is fixed and the timing to place an order varies. In the fixed time period, the time is fixed and the quantity varies.